The average US adult ingests about one credit card's worth of microplastics each week. As seen in a 2024 Stanford study, these microplastics don't leave the body, showing up in the brain, liver, blood, and even breast milk. This health crisis affects a reported 100% of patients tested. Microplastics cause cancer, dementia, heart disease, and infertility. Are you at risk for these complications? How would you know if you've never been tested?
Here at CDLC Biotechnology, we aim to address this gap with our Nanonet Microplastic Capture Tube, democratizing the affordable testing of microplastics in the blood. We've developed a specialized biomembrane made from bacterial cellulose with microplastic targeting enzymes. Only 3 milliliters of blood is needed, matching standard diagnostic workflows. Using a 500 micron thick membrane with 80 micron pores, we capture 90 to 95% of microplastics most common in human blood. The membrane is engineered with a multi-enzyme system designed to bind to the most prevalent microplastics, with membranes operating well below saturation, enabling reliable 3-minute sample processing from blood draw to shipment.
For manufacturing, our 20,000 square feet facility can produce 2.4 million tubes yearly. First, we cultivate our cellulose membranes in bioreactors, which are then inserted into our tubes produced in-house. They pass through a dispenser where trypsin gel is added to filter blood. After filling, tubes are capped and packaged for shipping. Each shipment also includes pre-filled syringes of a sodium hydroxide and urea solvent, allowing for easy membrane dissolution after testing. The Nanonet is a seamless add-on to existing blood tests. Blood samples enter our tube where trypsin lyses blood cells within 10 seconds, leaving behind plasma and microplastics. The tube is placed into a centrifuge, already super common in clinics, for a 2-second spin. Microplastics bind to the porous membrane, and everything else flows into the waste. The technician twists off the base, and the upper tube snaps closed, safely containing the membrane and microplastics. Our solvents then injected to dissolve the membrane. Finally, the tubes are sent back to our regional facilities where we perform plastic characterization.
The risk of membrane fouling can be mitigated by controlling enzyme activity and optimizing buffers. Thanks to ex vivo nature of blood tests, Nanonet qualifies FDA's 510(k) pathway accelerating regulatory clearance.
Our technology offers 3 key advantages. The first is our cost. Our production unit cost drops from about $8 to $1.59 per test within the first 5 years. With a market price of $45 per test, each tube has a massive profit margin. Tests are expected to be heavily subsidized by insurance companies, screening patients early to avoid covering more expensive procedures later on. This means consumers could pay as little as $5 or less, dramatically undercutting competitors like Blueprint and Numenor, who charge up to $180 per test. Second, our product offers technical superiority. Unlike existing solutions that rely solely on dynamic light scattering, our post-capture analysis uses micro-FTIR, scanning electron microscopy, and LCMS, delivering precise chemical, structural, and size data. Finally, our product offers scalability. With over 2 billion blood tests performed globally each year, and a blood diagnostics industry projected to hit $160 billion by 2030, there's a massive addressable market for Nanonet. We're seeking $10 million at a $100 million valuation. This funding will help us build our manufacturing and testing sites, jumpstarting our go-to-market timeline, and bringing our technology to clinics and patients nationwide. Our financial model projects a break-even point within the first year of commercial launch. By scaling manufacturing and clinical adoption, we expect to reach annual production of about 1.5 million tubes within the first 5 years, translating to a projected annual revenue of $105 million by year 10.
Together, we can launch the first generation of affordable microplastic monitoring, because what flows through our world flows through our blood.